Find the root of the equation 2 plus log of root of 1 plus x plus 3 log of root of 1 minus x, which is equal to log of the root of 1 minus x squared. Okay, so this is our equation, and we're asked to find the solution. So the root also means solution. Okay, so how can we solve for x? It says root, so there will only be one value for x. And in order to do that, we need to solve this algebraically. So let's rewrite this in another form, into a form that we can solve. So 2 plus log of root of 1 plus x plus 3. Now, since 3 is the coefficient of log of root of 1 minus x, I want to bring 3 to the power because there is, let's recap, a log identity. This is one of the logarithm identities. That log, so let's say we have a coefficient a log something, let's say, okay, a log something is equal to the log of that something to the power of a, right? Because let's say log of 100 is equal to log. Now, if we're only writing log, it is understood that it's to the base of 10. So we don't normally write 10 anymore. If it's log, then it's automatically to the base of 10. 10 squared is equal to 2 log 10, right? So that's the rule. And log 10 is technically just 1. 10 power of what equals to 10? It's 1. So yeah, it's 2. Or you can just directly write it as 2 because this is base 10. 10 power of what equals to 100 or 10 squared? It's definitely 2. But this is one way to think about it. So this is the rule, and the rule applies to this to powers in logarithms. So I'm going to rewrite this whole thing over here as, since this is root, right? So root is technically to the power of half. So 1 minus x to the power of half. And then to the power of 3, right? Whole, actually, let me erase that. Whole to the power of 3, like this. And then equal to log of root 1 minus x squared. Sorry, this looks unclear. Let me redraw this bracket, curly brackets. Okay, we have this. Now, what I'm going to do is I'm going to try and combine all the logarithms into one single logarithm, because these are all LGs. You know, LG is basically log, so these are all to the base 10. They have the same base. In other words, you can combine them using logarithm rules or logarithm identities. So let's continue. I'm going to rewrite this as, I'm going to write a little bigger, log of 1 plus x power half plus log of, I'm going to multiply it inside because the rule is if you have a m power n, it's the same thing as a m times n. And you can switch between the m and n. You can switch these two, the position. So this is also the same thing as a power n whole power m. So this is going to be 1 minus x power 3/2. So we're multiplying the 3 into half. So 3/2 equal to log of 1 minus x squared power half. And by our rule, since this is plus, so this expression plus this expression becomes log of this times this. Okay, so I'm going to combine them. 2 plus log of 1 plus x power half times, now 1 minus x power, whole power 3/2, but then we know that 3/2 is just half times 1 minus x power 1, right? Or just 1 minus x, like that, which is equal to log of 1 minus x squared power half. Now this also comes from the rules, one of the rules of indices, which is like this. So a power m plus n is equal to a power m times a power n. So yeah, we're technically just rewriting it as 1 minus x power half plus 1, which is the same thing as 1 minus x whole power 3/2, right? So we're just splitting them based on this rule. Okay, now why did I do that? Because now, as you can see here, these two are like 1 plus x and 1 minus x. They're differences in two squares, and there's a formula for that, which is this formula right here. A squared minus b squared is equal to a plus b times a minus b. Now, since the powers are the same, half, make sure that the powers are the same, or else you can't multiply these. So multiply them, and we'll get log of 1 minus x squared power half times 1 minus x, which is equal to log of 1 minus x squared power half. Okay, now I'm going to bring this whole expression to the other side, so it's going to be minus 2 equals to log of 1 minus x squared power half minus log of 1 minus x squared power half times 1 minus x. Okay, so this log a, oh, I forgot to write the rule for this. Let me write the rules. So log of a plus log of b is equal to log ab, right? And that's why I can combine these two into this, because of this. And then this, I can combine these two as well, because they have the same base. Log a, but the only difference is that the sign is minus. So log a minus log b is equal to log a over b. Yeah, log a over b. So hence, this is going to be, if you combine them, where is log? LG. You can write it as LOG or LG. LG is just to shorten it. So this is going to be 1 minus Sorry the video was cut before, but we're here. 1 minus x squared, I'm just writing this part, to the power of half over log of, oh, my bad. You don't have to write the log anymore. No more log here. Times this expression inside the log, which is 1 minus x squared power half times 1 minus x. Okay. This whole expression, I'm going to go here, and this whole expression can be simplified, right? So 2 is equal to, I'm going to use a different color, I'm going to use red. So these two will cancel, since they're the same, is equal to just the log of 1 over 1 minus x. So by definition, remember the snail rule, I like to think of it that way. So snail rule say this is base 10, right? So 10 power 2 is equal to this expression. So 10 power 2 is just 10 squared, just 100. 100 is equal to 1 over 1 minus x. Yeah. And then I'm going to bring this to the other side, or multiply both sides by 1 minus x, and I'm going to get 100 minus 100x is equal to 1. And then 100x equal to, bring this here, 99, 100 minus 1 is 99, thus x is equal to, thus or therefore is this simple, 99 over 100. 99 over 100. This is our final answer. I'll write it neater. 100. Okay, so this is our final answer. X. So the root is x. And x is equal to 99 over 100. Or you can also write this as 0.99. So, or maybe if you don't want to write it in fraction form, this is also equal to 0.99 in decimals. Thank you.